This standard is about linear regression. Linear regression is often used in the real world. Typically, people run an experiment, get some data, and then if you plot it, and the data can be plotted along a straight line, often people will make a linear model, and this model is used to predict how future experiments will come out. So we've talked about predicting before. Remember, at the beginning of Unit 2, we talked about functions, and one of the ways we explained it was that a relation was a function if it could be used to predict how an experiment would come out. If I gave you a value for x, say 2 seconds, you would know what y would be. It wouldn't be that there would be a bunch of different choices. If you have a linear model, if you're at a certain x value, you're always going to be able to know what the y is. So we're going to use the function notation a lot for many of the linear equations we find in this section. So here's an example of an experiment that was run. A ball was rolled down a hallway and its position was recorded at 5 different times. So we're going to use the data given in the table, and we're going to predict the location of the ball at 12 seconds. So first what I'm going to do is I'm going to make a scatter plot. So I need to label the axes. I'm going to use time for the x-axis. And time was in seconds. So 0, 2, 4, 6, 8, 10. And that should cover all my data. For position, I need to go up to 23. So let's move this, there we go. Position, and that's in meters. So I'm going to have these go by 2 so I can get all the way up to 23. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So now I'm going to plot all the data. 1 goes to 7. 2 goes up to 11. 4 goes to 20. 6 goes to 21. And 8 goes to 23. So I'm going to do my best to draw a straight line that goes through all those points. If I was using paper and pencil, I'd use a ruler. I don't want to mess up my Explain Everything iPad app here, so I'm just going to kind of make a guess at it. So there's a line that pretty much goes through the data. What I need to do now is try and figure out what the equation of that line would be. So I'm going to pick 2 points on that line, and then I'm going to use some of the methods that we learned in earlier sections for making the equation of a straight line. So I'm going to look for some points that where the line crosses some grid points pretty nicely. And they don't need to be points from my original data set. I'd like to pick some points that my line went through. So I'm going to pick this one here. And where else does it go through? Let's go with this one here. Now I'm going to make an equation from those 2 points. So we've done a lot of work in previous sections making equations using the slope-intercept form of a line. Y equals mx plus b. So let's go back and look at my 2 points. I picked 1, 7. And I also picked 3, 14. So you may recall, to find the equation of a line given 2 points, the first thing I have to do is find the slope and then go back and find the y-intercept. So the slope is y2 minus y1 over x2 minus x1. So y2 minus y1 is 14 minus 7 over 3 minus 1. So the slope turns out to be 7/2. So I'm partway to the equation. I know that it's 7/2 x plus b. And to find b, I can pick one of those 2 points and do some arithmetic. I'm going to go with 1, 7 because the numbers are smaller. So 7 equals 7/2 times 1 plus b. So 7 equals 7/2 plus b. 7/2 is 3.5. If I subtract 3.5 from each side, I get that 3.5 is b. So the equation of the line is y equals 7/2 x plus 3.5. Now I want to use this equation to predict, let's go back to the question, the location of the ball at 12 seconds. That means in place of x, because x was my time axis, I'm going to go ahead and put 12. I'm going to put this on another page. So my equation is y equals 7/2 x plus 3.5. I'm going to use function notation for this. Linear equations are functions. This would satisfy the vertical line test if you went back and drew a vertical line over the line of best fit we just found. So I'm going to practice with function notation. In place of y, I'm going to put f of x equals 7/2 x plus 3.5. So if I want to find how far the ball rolled at 12 seconds, I'm going to be finding the value of the function at 12. So f of 12 equals 7/2 times 12 plus 3.5. Make that 12 over 1. That reduces to 1 and 6. So the value of the function at 12 is 42 plus 3.5. So that means the ball rolled 45.5 meters after 12 seconds.